Hello everyone, here are the answers to just number 8, the 3 parts. You could take a look at the post that I have, Solutions with Work, or at the back of the textbook pages, the last couple pages there for problems 1 and 3. So today we're still going to go through section 4.5. Here we're going to use the linear approximation formula from yesterday to help us solve equations. This is using Newton's method for solving equations. So if you want to read a little bio on Sir Isaac Newton, you can pause the video and go ahead. All right, so let's say our function f of x, we want to solve this. We're going to set it equal to 0. A function must be equal to 0. That's how we're going to solve it. So we're really trying to find like where our function crosses the x-axis. So our function must be set equal to 0. Now the CAS calculator uses this. It's the solve feature. This is what's programmed in there. So we saw from yesterday that f of x is approximately whatever our linear approximation turns out to be, which again from yesterday is f prime of a times the quantity x minus a plus f of a near x equals a. So we're going to go through a little sketch of a graph for this as well. So let's let our function, our curve, look something like this. All right, so right now at my very specific x value here, or a, I'm going to go back to x sub 1. So let's let a equal x sub 1. So let's say my x sub 1 is somewhere over here, and I'm just spacing it out. Eventually I want to find where our function crosses right there. So this is going to be my initial guess. So now I'm going to go up to my curve and make a point, and I'm going to draw in my tangent line. So again, we're going to let x, or a equal x sub 1 be the initial guess of the solution. And then we want to find the linear approximation of that. So I'm going to write this out. I'll call this L sub 1 of x is going to equal f prime of x sub 1 times x minus x sub 1 plus f of x sub 1. And I'm going to set that equal to 0. I want to know when this is equal to 0. So when is this tangent line going to equal 0? Now we're going to just solve for x. So what I'm first going to do is subtract f of x sub 1. So now f prime of x sub 1 times x minus x sub 1 is going to equal negative f of x sub 1. But the x I'm trying to solve for is this one right here. I want to get that by itself. So now my next step is to divide both sides by f prime of x sub 1. So I no longer need the parentheses. X minus x sub 1 is going to equal the opposite of f of x over f prime of x sub 1. That should be an x sub 1 there too. So now to get x by itself, I'm simply going to add x sub 1. I'm going to write that first. So x is equal to x sub 1 minus f of x over the derivative, again, sub 1 of x sub 1. But I'm actually going to call this now x sub 2. So if I go back up to my graph, this is now where it took me to. And I'm a little bit closer to the actual point of intersection there, the x-intercept. So now I have to repeat the process. So this right here is where the line crosses the x-axis, which is why it took me to that x sub 2. So this tells us we're getting closer to the right solution. So let's do this again. But we don't have to go through the process. So let's go back and go through this again. So if I replaced all of these with x sub 2's, I would still get all of this here. All of my x sub 1's would just be x sub 2's, and then I would call that x sub 3. So that's what we could kind of jump to. We know that x sub 3 is going to equal x sub 2 minus f of x sub 2 over f prime of x sub 2. So let's go back to our graph. So this means now, if I go up to my curve right here, and I draw in another tangent line, and I want to see where that is going to cross. So now this is my x3, so it's moving us closer and closer. And we can continue this process, so now we would say x sub 4 is going to equal x sub 3 minus f of x sub 3 over f prime of x sub 3. So again, just to repeat, this is the solution when L sub 2 of x is equal to 0. That's our second tangent line that we drew in where that crosses the x-axis. And this is the solution when L sub 3 of x is equal to 0. That's our third tangent line, and it's moving closer and closer to the actual solution. So eventually, x, we say, will converge or approach a solution. So what we've created here are called iteration formulas. There's two ways we can look at this. We could say x sub n is going to equal x sub n minus 1. So if this was, if 4 was n, 3 is n minus 1, minus f of x sub n minus 1 over f prime over f prime of x sub n minus 1. Or we could look at this as x sub n plus 1. And then over here would just be x sub n minus f of x sub n over f prime of x sub n. Second version is a little bit easier to look at with just the n's instead of n minus 1s. All right, so we're going to use our calculator here. We're also going to use our knowledge of some basic graphs. We're going to go through one example. We're going to use Newton's method to solve this equation to 12 significant digits. So make sure on your calculators you take this out to float 12. So the first thing we want to do, remember we always want f of x to equal 0. So I'm just going to move this 2 over. So that means we're going to have x cubed minus x plus 2 is going to equal 0. So that really means f of x is equal to x cubed minus x plus 2. Then we want to find f prime of x. So that's just going to become 3x squared minus 1. So then we're going to define Newton's equation or Newton's function, and this is how we're going to type it into the calculator. Newt of x is just going to be, we really don't need the subscripts here, it's just x minus f of x, so there's x cubed minus x plus 2 over f prime of x, so that's 3x squared minus 1. Well, we need an initial guess here. We have no idea what to guess right now. That's where the graph is going to come into play. Now, for the graph, I'm going to treat these as two separate functions. So first I want to take a look at y equals x cubed minus x, and then I want to graph y equals negative 2. So for y equals x cubed minus x, I'm going to factor this into x, and then it's x squared minus 1. So then this becomes x, x plus 1, x minus 1. So if I were to find those zeros just of the x cubed minus x, I know this graph is going to cross at 0, at negative 1, and then at positive 1. And then down here, let's say, here's our negative 2. So because this graph x cubed y equals x cubed minus x has a positive leading coefficient, I know that my graph is going to come up through x equals -1, turn, come back down. I don't know how high up it goes or how far down it goes either. But I do know right now if I were to graph my line y equals -2, this is what I would have. So this right here is going to be our initial guess. So I'm just going to go closest right here to -1. So how about our initial guess is x equals -1. So what we want to do on the calculator, let's go ahead and define. So go to menu 1, we want to define, and we're going to type this in, NEWT of x is going to equal this right here. So go ahead and define that in, and then just hit enter when you're done. Calculator is going to do all the work for us. All right, so once you have that saved, you want to go to the variable key, go down to the newt function. If that's the only one you have, that's fine. And then type in -1. Now for all of these, you may need to hit Control Enter if it doesn't give you. If it gives you a fraction, you just go back and hit Control Enter. So this gives us -2. So what we want to write in now is that newt of -1, it actually comes out exactly to -2, but for everything else we're going to say approximate. Now we're going to repeat the process. We're going to say newt of -2 So here you want to hit Control Enter. Now we're going to say this is approximately, and it looks like a -1.63 repeating. So if it repeats, you could just put the bar over it. And we're going to repeat that process. But I don't want to have to write these, especially if we're carrying them out to 12 decimal places. I'm just going to go newt of answer. And again, that just means the previous answer here. So remember, if your calculator is not showing 12 significant digits, you want to change your float settings there. All right, so we should be getting a -1.53039.205.213. So what we're going to do is we continue this process until we see the same exact number show up. So we'll do this one more time, see what happens. Newt of answer is approximately. So just go to newt. Remember, you can just go back up to the previous answer and hit enter. So it's a little different. We should be getting a -1.52144.146.514. We'll do this again. Getting closer, we could see now we're still at at least the first several digits are the same. We're getting a -1.52137.970.973. Let's try this one more time. Even more digits are the same. Now we have a -1.52137.970.68. There should be a 0 after that. And I think one more time does it. right, so yes, if you did this one more time, you get the same exact number. We still need to write that. We want to show the spot where it does repeat here, but we cut it off because we're going to count the iterations here. So as soon as it starts to repeat, we stop, but we need to check that. So then we count. This happened we did this once, twice, 2, 3, 4, 5, 6 times. So we would say, therefore, the solution is x is approximately negative 1.52137970680, and it took 6 iterations to converge. And you can always check using the solve feature as well. Go back up to the original. However, this is what we want to do. This is the process. So we figure out what f of x is. We want to show that we're setting it equal to 0, but then we take the derivative here, because this is really what we're solving. Then you keep them separated. So if it's given to you like this, that's fine. You leave it this way. If not, then you do want to move the constant or whatever is over to the other side. That way you have 2 basic graphs. And then this is what's going to help you get that initial guess. If we're too far away and the tangent lines change, we're never going to get to our answer. So we want to find something that would have consistent tangent lines here. So that's why I started with -1, and it kind of pulled us closer. So we were at a -1.52. All right, so a few to try. Numbers 15 and 17 from page 229. Please do AP page 1, number 1. And then an additional one, 15 and 17 are very similar. But for 2 to the x is equal to 4 minus x squared. Solve this or find all solutions up to 12 decimal places, and then make a sketch of, again, you could treat this 2 separate sides just to show what your initial guess is. All right, so enjoy this assignment. Let me know if you have any questions.